All right, now we're going to introduce factoring polynomials with the greatest common factor. And there are 4 steps to factoring victory. This is the first one. We have got to be able to identify a greatest common factor. And so what we're looking for are 2 things. We're looking for the greatest common factor between the 2 coefficients. So the GCF of the coefficients. And then we look for a common variable. So I'm going to say GCF for the common variable. Now, specifically, we're looking for a common variable, and then we're looking for the most amount that they have in common. So we find the lowest exponent present on any variable that we have in common. Now, in this problem, we don't have a variable part in common. This one has an x to the 4th, and there's no x on this one, x to the 0, if you will, which is just a 1. So technically, there is no common variable part for this one. So we just focus on the GCF of the coefficient. Between these, there's a 40, and this one has a constant. It's not really called a coefficient, but you could if you focus on it as x to the 0. But 16 and 40, so we just have to think through products, factors that multiply to be 16 and 40. The biggest number that goes into both, well, 4 goes in, but you got to go all the way up to 8, and then you can think through whether or not 16 even might go into 40. And so the biggest that we have is 8. So 8 goes in to each of these. So our job is to write 8 in front of a parenthesis, because we're kind of backwards distribution is what's going on. We're undoing distribution. So what I want to do is individually divide each term by my greatest common factor. So I'm dividing the 16 by 8, and the result goes inside these parentheses, and I get 2. I take the negative 40 and divide it by 8, and then I take the result and put it in the parentheses behind the 2. Now, focus on the fact that it was a negative 40 divided by 8. Negative 40 divided by 8 should be negative 5x, and then to the 4th power remains because there was no variable part in common. So this is fully greatest common factored of this polynomial. In this second example, we're going to follow the same process. Look for the 2 things, the greatest common factor for the coefficient or the number part, coefficient specifically. And then we're looking for the greatest common factor of the variable part. Now, this time we actually have a variable part, so that's good. We get to see a little bit of both. And then the GCF this time, we want to recognize that they both have a negative. So when that happens, the coefficient part, we do want to go ahead and take the negative with it. So I need to look at the negative, and then I also want to identify between 24 and 6, the greatest common factor that goes into both of them. And 6 goes into 6, and it also goes into 24. So 6 is going to be my number. So I'm going to factor this out by pulling out a negative 6. And then I'm going to put parentheses. As always, you put your GCF in front with a set of parentheses. Now, I probably made that a little too tight there because I'm going to throw an X also. My greatest common factor variable part is the common letter that they have, and then the lowest exponent. This time, the exponent is a 5 here and a 1 here. Well, the 1's the lowest, so I want to put an x to the 1, or just put x. You don't need to put the 1 there. That is my GCF part. So what I need to do now to get what's inside the parentheses is divide each of these terms by exactly negative 6x. So then you work through what negative 24 divided by 6x is. I'm going to erase all my scribbles on there. So So negative 24 divided by 6x, the negative should reduce, and then 24 divided by 6 should be 4. And so I'm going to have that turn into a 4, and then the x's reduce so that it's just a 1. So the leftover after division is 4. Factoring is dividing, and so we're just doing division in this case of our greatest common factor. So I'm going to take negative 6x to the 5th and divide it by negative 6x to the 1. The 6 is negative 6 divided by negative 6 is going to turn into, and you got to think that through, negative divided by negative is positive, and 6 divided by 6 is 1. So it's positive plus 1. I'm going to have to put a plus over here in my answer. And then the x to the 5th, I need the divide by 1 variable, 1x. So what happens is subtraction. 5 minus 1 is 4. So x to the 4th remains. So it's 1x to the 4th that goes over here in the box. Positive 1, you don't have to write the 1, x to the 4th power. So my answer is negative 6x times 4 plus x to the 4th after factoring. My greatest common factor of negative 6x. All right, in this third example, we're going to up the rigor a little bit more. Now we've got a variable part that has a number that's higher than 1. Now, one of these is negative and one of these is not negative. So now we get into a little bit of a conversation about whether or not to factor out the negative. So part of the decision I would make with that negative is I would look at this, and I haven't focused on the fact that none of the problems so far have been in standard form. And so if I was to just put this in standard form and reverse the order to make it 7x to the 4th and then minus 14x squared, I would not now pull out a negative. The way it was, where if it was a leading coefficient that was negative, I would factor out the negative. In this case, I would not, simply because my leading coefficient is a positive 7 in standard form, so I'm not going to pull out the negative. But again, there's two parts to GCF. I'm going to look at the number, the coefficient part. So look at the numbers, just the coefficient specifically. And 7 and 14, they have a common factor of 7. And then the variable part, I'm going to look for the common variable. They both have x, and then it's the lowest exponent is 2, so x squared. So putting that together, 7x squared is what I'm going to factor out. So 7x squared, and then you need to divide by 7x squared is the process of factoring. And 7x to the 4th divided by 7x squared should reduce the 7's to be positive 1, and then you take these two x's and subtract 2 from the exponent up above, so x squared is what's left in that parenthesis, and then you divide the negative 14 by 7x squared, and negative 14 divided by positive 7 should produce a negative 2, and the x squared divided by itself is 1, so just a negative 2 should go back here. That is the result of my GCF. 7x squared times x squared minus 2. Now in this example, we're going to get one more layer. Now we have two variables. The coefficient part is the first part we look at. The GCF of the numbers this time, the coefficient specifically, when I say numbers, there's just a 1 out in front and then a negative 1 here. So I'm going to say that there's just a 1. There's always something you have to factor in. In this case, it's just the number 1. So my variable part this time, the GCF variable, as I've been saying so far, is we look at a common variable and then the lowest exponent. So this time we have an x in the first term, but there's no x in the second term. So x is not in common. Y is in common, and they both have y's. And then I look for the lowest exponent on my y's, which in this case is 2. So my GCF variable is a y squared. So putting that together, my GCF, my greatest common factor, is y squared that I'm going to divide from both terms. So then I come through and actually do the division on both terms, where dividing the first term by y squared will simply get the y squares to reduce out, because anything divided by itself is 1, And so the result of division is just x to the 5th. And then I've got negative y to the 4th is my second term. Dividing that by y squared, you reduce by subtracting the powers. So this 4, I subtract 2 of them. So then I'm left with 2. So this is just a negative y squared after dividing, factoring out my y squared. So negative y squared. And I haven't mentioned so far, but you can always distribute your y squared and double check that that would give you what you started with. But this is the result of my factoring y squared times x to the 5th minus y squared. Now we're looking at a problem where we've got two variables in common. So first thing we look for is our greatest common factor coefficient. And what we're going to find is the number part is that it's just 1, just like the last problem. And then the second thing we look for is our variables. And our variables, we have an x and a y on both terms. So xy there, xy here. So then what we have to do is pay attention to, okay, well, how much x and how much y do we actually have in common? So to do that independently, you have to look for the lowest exponent that's present. I have a 3 on the x, but then over here I have an invisible 1. So the 1 is my lowest exponent, so that's the greatest amount that I can divide or take out. So now transition to the y. If I look at the y, I have a 4 here and a 5 here. The lowest of those is 4. So 4 is the exponent that I'm going to put on my GCF. So putting these together, it's 1, x to the 1, y to the 4th. This is my GCF. So I'm going to write that out here in front of a parenthesis, x to the 1, y to the 4 times. And then the result of division by this x, y to the 4th is going to be my factored binomial when I'm done here. So let's go ahead and divide each term by what I identified as my greatest amount that's in common. So I take x to the 3rd, y to the 4th, and I divide it by x to the 1, y to the 4. And when I divide by that, the y to the 4ths reduce completely because anything divided by itself is 1. But then the x part, I've got 3 x's up top, and I'm reducing by 1 x. So I subtract my power and make this a 2. So x squared is the first term in my quotient. So then I have the second term needs to get divided by x, y to the 4. And so again, anytime you divide anything by itself, the x's, that reduces to be a 1. And then y to the 5th divided by y to the 4, you subtract powers. And so you're just left with 1y. And it's a positive 1y. And then we have our result of factoring our GCF of x, y to the 4th. All right, continuing to add another layer. This time we have both steps of our coefficient and a variable in common and multiple variables in common. So first step is to look for your GCF number part, coefficient part. And the coefficient here, we have 24 and 9. So we look between 24 and 9 and see what they have in common. Well, 9 doesn't go into 24, but 3 goes into both of them. So 3 is our coefficient GCF. And the second part, we look for the GCF with our variables. And our variables, we have x, y, z on the first one and just an x and a y. So just the x, y is the overlap there, x, y. But then we got to come back and look at our powers. Well, this is 7 on the x and then 3 on the x. You look for the lowest power. The lowest power present is 3. So then I look at the y's. I got y to the 3rd and then I got y to the 7th. The lowest power is what's in common between 7 and 3. So this 3 is the lowest for the y's, and this 3 over here for the x's was the lowest there. So 3 x to the 3rd power, y to the 3rd power is what I've got as my GCF, the variable part. So x to the 3rd, y to the 3rd. Now I got to put these together. So the coefficient goes in front of the variable part. So my amount that I'm going to factor or divide out is 3x to the 3rd, y to the 3rd. So the work I was doing was leading up to deciding what to divide out. And now I go through and divide it by each term. And so I go through one at a time, systematically divide by my coefficient, 3, and then my two variables, x to the third, y to the third. And then work it out, 24 divided by 3, and then bring my answer over here, 8. I got x to the third is going away from x to the seventh, so I'm subtracting those 3 from the 7 to get 4. So that's 8x to the 4. And then I got to do my y's. I got 3 y's on the bottom, 3 y's on the top, so there's no y's over here in my result. But there is a z to the fourth that's just hanging out. So put z to, or sorry, I said the second. I think I said fourth. Z to the second. So that term is done. So now I take 9x to the third, y to the seventh, and divide it by my GCF of 3x to the third, y to the third. And 9 divided by 3 is going to give me 3. So I put that, and it's a positive 3, so plus 3. And then the x to the third reduces out because anything divided by itself is 1. And then I just have to subtract my powers with the y's. I got 3 y's on the bottom, 7 on top. That subtracts to be 4. Y to the fourth on the top is what's left. So this is my result of factoring my greatest common factor of 3x to the third, y to the third. All right, in this final example, we're again looking at our two things to worry about, our GCF of coefficients and our GCF of the variable part. Now this time, both coefficients don't have a number that goes into 23 and 21. What we do see, though, is that they're both negative. So it's kind of a choice here, and I'm going to choose, I'm going to factor out a GCF of a negative 1 this time. You don't necessarily have to factor out the negative. It's just prudent and beneficial for when we're going to be factoring and graphing polynomials later. But here I am going to factor it out. And then second part, my GCF of the variable. So this is my number part. And then the variable is going to be a couple threefold. It looks like I've got x on both, I've got y on both, and I got z on both. So x, y, z are all in common, and then I have to go back through and decide, well, how much of each one? Well, there's 3 x's and 7 x's. The lowest is the one that you take, so x to the third is how much x's I can take out, how much is in common. And then for the y's, I've got 4 y's on the first one, 7 y's on the second one, so the lower of the two is 4, so I put 4 as my exponent on the y. And then I go with the z's, and I've got z to the third on the right one, and z to the fifth on the left one, the lower of that being the 3. So 3 is how much z I can take. So my GCF combines those, the number part and the variable part. I multiply that together. So it's negative 1, I don't have to put the 1, x to the third, y to the 4, z to the third is my GCF for this problem. So now I have to go through and divide out my GCF from each term to get my final factored result. So let's work it one term at a time. So divide the first term by a negative x to the third, y to the fourth, z to the third. So one term at a time. The negative divided by negative is just a positive 21. So I'm going to bring that over here. Positive 21. And then my x to the thirds reduce out. My y to the fourths reduce out. And then I just take my z to the third and subtract powers, is the way the property works there, for same basis being divided. So this is z to the fifth minus 3 in the power, which is going to be z squared. So 21z squared is that first term result. And then I work through the second term. Divide that by a negative x to the third, y to the 4, z to the third. First thing, negatives divide out. So that's going to be a positive 23. So plus 23. The x's reduce by subtracting from the 7 up top, 3 of them to get you 4. And so that's going to be x to the 4. And then the y to the 4th on the bottom takes 4 from that 7 up top to be left with y to the 3rd. And the z's reduce out. So this is the result of factoring my greatest common factor of negative x to the 3rd, y to the 4th, z to the 3rd, 3 variables, and a negative.